In this video, we'll expand on several of the ideas presented about columns in the previous lesson, talking specifically about data types and other properties that allow you to define columns that enforce a high degree of integrity and therefore usability of your data. In the previous lesson, we said that tables are comprised of one or more columns, and that columns are made up of three basic ingredients. First of all, a column is going to have a name. It's going to have a data type, and then there might be some other properties that are associated with that given column. And this isn't an exhaustive list by any stretch of the imagination, but they're probably some of the more common ones. We already talked briefly about whether or not this particular field of information can have an automatic numbering sequence. Obviously, this would be applicable to those numeric fields. And we'll show in this video later on how to set an identity column. We already looked at whether or not a field can be empty or not by setting the nullable property for a given field. We haven't really covered this yet, but is this particular column that we're working with a key field in relating the table to other tables? And so we can set a property that basically designates this as a primary key or whether it's used as a foreign key. And then also there are properties that allow us to define default values so that as a new row of information is being inserted into a table, so a new record is being created, a particular field of information, if not specified, can default to a certain value. And again, that's something that can be dictated by the definition of the properties for that given column. Now you might be asking, why do we need to go through all this effort to adorn our columns with all this extra information? Are these extra properties really worth all the learning curve that we have to put into really understanding what they do and how they affect the design of our tables? And the emphatic answer is absolutely. Not only are they important, but they're really an integral part to creating a usable data store for our data. Now, in most cases, they not only enforce integrity, but honestly, they can make things much easier than, say, trying to accomplish the same sorts of results purely with Visual Basic or C# code. And more importantly, employing some of the special properties of columns reduces the headaches that you encounter down the line as your application expands and grows to your needs. Because after all, a good data store isn't worth anything if the data inside of it is worthless. And the data type as well as the other properties give you the tools to maintain a high degree of integrity to ensure that your data is meaningful and useful for the purpose it was designed. So how exactly is data integrity enforced through the use of data types and column properties? Well, I've got a couple of ways listed on this slide. For example, ensuring that the data is of the correct data type means that no longer will people be able to put random values into their applications to store currency data or to store date-time data. Invalid entries are eliminated by specifying the data type that can be stored in the database, because you don't want information to be inputted improperly, or else the reporting on that data becomes impossible. It's also important that some information is not allowed to be left blank, that there's certain information that you define up front that has to be there before we can save a record of data into the database. Or else that row of data is virtually useless if we don't have a first name and a last name for a customer, for example. And then similar to some of the other points that we made earlier, that just making sure that the data falls within an appropriate range of values that are expected. So we don't have currency values where dates should be and vice versa, and that the dates, like we did in the previous lesson, we're not trying to enter dates from the the 3rd century. But rather we're storing meaningful dates for events and things that have occurred at this point in time. So defining some of this doesn't solve all of your problems. You're still going to have some issues of the accuracy of data. However, as much as it is possible, by using some of these tools, your data becomes more reliable than, say, had it been stored in a simple flat text file, a flat database structure, or an Excel spreadsheet, or whatever the case may be. So when we're talking about restricting the kind of data that can be inserted and updated within our databases, conceptually we're talking about constraining the data or placing constraints on our tables. And a constraint is simply anything that we do to the definition of the table's columns that in some way restricts what is allowed to be input into the table's rows in any way. And so there's several different ways that we can enforce data integrity through the use of constraints. A data type is a type of constraint. When we talk more about relating tables to each other, that's a special type of constraint called referential integrity. We'll talk about that in the next video. And then there's other special rules that we can place on columns, special constraints that would allow us to perform more complex operations, like looking up to seeing if other values are present before it allows an insertion of data. And these kinds of programmatic checks and constraints can be implemented through SQL Server. That's a little bit more advanced. We're probably not going to cover it in this particular video series, though. But although I think the really the gist of this particular slide and the lesson up to this point is that even though usually we think of constraints as a bad thing, a restriction is a bad thing, it's actually one of the best friends that we have as developers and administrators of databases, because it eliminates some of the possible badness that can happen within our applications whenever bad data happens. Whenever somebody tries to input bad data into our database, we can stop it and not allow it, and continue to make our data useful and our applications useful and less prone to errors. Okay, so now that you're on board with the use of constraints and you love the concept of using data types because that really makes your database more useful in the long run, the inevitable question, with so many options available to you in terms of data types to use whenever defining your columns, is how do I learn what all these data types are? I mean, there's so many of them to choose from. And so my suggestion to you is to really just get to understand and get familiar with some of the most basic data types, and then grow your collection and your knowledge of data types from there. Similarly to how you did it whenever you were learning Visual Basic or C#, for example. So as a rule of thumb, you can generally use the int or integers for big numbers, and we're talking really big numbers in the millions and millions. Usually integers, in fact not usually, integers cannot have decimal points, so they have to be whole numbers. If you need small numbers, in the interest of keeping the size of the data, the footprint of the data on your physical disk drive as small as possible, we would want to maybe use tiny int or small int for smaller numbers, where we only need hundreds or thousands instead of millions and so on. If we're expecting a lot of text, we can use varchar. If we're expecting a lot of text, we can use the new varchar max. So in the previous lesson, you saw how we defined varchar 50, 50 being the length of that given field. So the maximum size of that field can be 50 characters in length, but it expands and contracts to really accommodate the amount of characters that we're going to place in there, up to an absolute limit of 50. Well, if we needed a lot of text, maybe like paragraphs of text, and we don't really know how much data we're really expecting there, then in some rare situations we can use varchar max, which would allow us to put just as much information, as much textual information, paragraphs and pages of data inside of that particular field of data. Now, if you have a need for any special characters, maybe other character sets like Japanese or Chinese or whatever the case might be, you can use the nvarchar, which is the equivalent to varchar, except that it allows for Unicode characters. In most cases, a small date time field will suffice for your date and time needs. What's the difference between small date time and date time? Simply put, you just don't need sometimes fractions of a second, so you don't need the date time field. Small date time excludes fractions of a second, therefore it's usable for in most cases. Again, if you need some type of currency to be saved, small money will suffice. The regular money will allow for more spaces after the decimal place, larger sums of cash. Small money works in most instances for your typical transaction sizes. And then if you just have a simple field of information where you need to store on or off, yes or no, the bit data type will suffice for that. It'll save as a 0 or 1. Now, if you're in doubt, take some time and go through the SQL Server help files and look up data types and review what range of values can fit in each of these and the other data types that are available to you. Because selecting the right data type is so important. And so that's why I inserted this slide, because I want to impress upon you why it's important to select the proper data type for your application. We could go through and define everything as varchar 50. But having gone through a review of why data types are so important to constrain the data and to make it more useful, we need to really be about the task of researching and making sure that we're using the right data types for our applications. If we select a data type that allows too much information, more than our application would need, then we're wasting space, and usually that's not a large issue for us nowadays in smaller applications, but for very large applications, at more of an enterprise scale, selecting the right data type is crucial. And selecting the wrong data type could cost our company thousands, if not hundreds of thousands of dollars. Now, if we select too small of a data type, then we put an artificial ceiling on what our application is able to accept. So we certainly don't want to do that either. If we select the wrong data type, then getting the data into and out of the database becomes very time-consuming and frustrating process. We have to convert the data type to the correct data type for use in our reports and our applications, and then convert it back for storage back into the database. And from personal experience, this can often be a very, very painful process. So selecting the right type reduces the amount of data conversion that we need to do in and out of our data store. And then it also makes, as I've just kind of alluded to, reporting more difficult, especially in regards to some of the functions that we can perform on the data. Let me give you a couple of examples where you can see selecting the right and wrong data types can make a difference. Say, for example, zip code. Now, in the United States, we have either 5 numbers or it's 9 numbers, right, that can represent a zip code. They're all numeric values, and we can expect it to be either 5 or 9. So our first thought might be to use numeric columns, maybe a small int or just the regular integer value. But those are really reserved for those times whenever you need to perform some type of aggregation of the data. So we need to get a sum of all of a given column. We need to add up all the numbers. Or we need to perform some mathematical equation on the data. Or it represents a true value as opposed to just a designation, which is really all the zip code or the postal code is. And then also when we keep in mind that in other countries that the zip code, or rather the postal code, can be more than 5 or 9 characters, and that it often includes alphanumeric characters. So, for example, in Canada, it's alphanumeric. Then defining zip code as an integer or a small int really places an artificial ceiling on our application, not allowing people from other countries to interact with our application. Similarly, we could store money values as integers, but in doing so, as we'd only be able to store whole numbers, we wouldn't be able to store any values after the decimal place. Now, in some applications that might make sense. However, I think it's always a good idea to either use money or small money whenever. Okay, as we finish up this lesson, let's talk about the importance of the identity column. We first noted the identity column in the previous lesson, um, and now it's time to go back to that example and modify one of the columns that we defined for our customers table to make it an identity column. But what is an identity column? Well, it's basically a special property that allows us to define a one column that will automatically increment or decrement based on our settings so that we can get a unique value in each row of that given table. Now, why we do that might not be so obvious in this lesson. In the next lesson, it's going to become very obvious whenever we begin to talk about primary foreign key relationships between tables. But since we're on the topic of adorning our columns with properties, I felt like it was a really good idea to at least show you how to do that so when we get to the next lesson it becomes not an issue of how do you do it, but the importance of it. So let's go ahead and switch back to the example from the previous lesson. And as you can see, I have the My Sample database opened. And we have our loan table customers open in our main area so that we can change some information about our table. We're going to focus specifically on the customer ID column, and what we want to do is set the identity property. So if we scroll down, you can see at near the bottom that there is an identity specification with a little plus minus area that allows us to open up some more information about whether or not this column is defined as an identity column. So the first thing we want to do is change no to yes. We want this to be an identity column. And notice that we get two additional properties that we can define by setting this to yes. We can set the identity increment and the identity seed. The seed is the first number that we'll start with. So for in this example, I know that we've already got a record number 4 in our database. So we'll start with an identity seed of 5, or better yet, let's start with an identity seed of 8, just so this becomes very obvious as to how it's used. And then we'll set the identity increment to 1. Now we could set this to 2, and so whenever we add the next record into our database, it will be 10, and the next record would be 12, and the next record would be 14, and so on. Or we can set it to a -1, which would allow us to start at, say, 1,000,000 and then count down from there, reducing the number by 1 each time. Of course, that would put potentially an artificial ceiling, but we're able to do that by defining a -1 in this place. 1 is fine for most purposes, so we'll leave it at 1. And now that I've defined both of those values, I'm going to go ahead and click off of that and then select Save on the toolbar. And then I'm going to close this and then right-click and select Show Table Data so that in the main area we have that, that table view. And I'm going to add a new person here, Brian Faley. And we'll do something like 4/1/2006 and amount spent 2,500. Now notice that I did not fill in the customer ID. I left it null. When I hit Tab to insert this record, we hopefully will not get an error like we did in the previous lesson whenever we had a value that we needed. But in this case, when I hit Tab, it will automatically increment the next number to 9. Now let's do another one. Chuck Rivetto. And notice that it increments that customer ID to 10. So each time we add another record into the database, it will increment that customer ID by 1. Let's just play devil's advocate here a little bit and delete number 10 from our database. So I'm going to select it and then hit the delete key on my keyboard. I'm about to delete one row. Yes. And let's create another one here. And whoops, didn't really do a good job there. And we'll do 2006. And he'll have spent $1,400. And when we do that, it doesn't reuse the number 10, rather it increments to number 11. Now the reason why it doesn't reuse 10 may not be so obvious to you now, but when we start talking about referential integrity between tables, and we start talking about how to relate two tables together, and how we can potentially orphan rows in one table by deleting a record from another table, and then consider why we wouldn't reuse identity values once removed from the database, hopefully it'll become a little bit clearer. So we're slowly laying the groundwork, and we're just about ready now to talk about relational databases. Specifically, how do we relate two tables of information together? What's the benefit of it? How do you go about doing it? And how to implement that within our visual tools that we have available to us. And so that's really the punchline to all the discussion that we've had up to this point. Make sure to watch lesson number 4. And if you're enjoying this style of training, please visit www.learnvisualstudio.net, where we have over 500 screen cam video tutorials just like this one on all topics pertaining to .NET, C#, Visual Basic, ASP.NET, and many other topics. Thank you.